So far, we have seen IP addresses and subnet mask and how does it work. So now let's look into a concept which makes the representation of subnet mask much simple and much easier to understand. That is CIDR, classless inter domain routing. So what is classless inter-domain routing? So CIDR is a simplified method of representing a subnet mask. So what it does is CIDR identifies the number of binary bits set to 1 in a subnet mask and preceded by a forward slash. That's it. First, let's look into one example, then we'll get more clarity. So in this example, let's the subnet mask of 255.255.255.240. So this is our subnet mask. So when you convert this into binary, let's see how does it look like. So this is the binary form of the above subnet mask. Total it has 4 octets, and first octet all are ones, and second octet all are ones, and third octet all are ones. Whereas fourth octet consists of 4 ones and then 4 zeros. Now, so as per the definition of CIDR, so what it does, CIDR just identifies the number of binary bits set to a 1 in a subnet mask preceded by a slash. That's it, preceded by a slash. So here 8 ones plus 8 ones, 16 ones plus 8, 24 ones plus 4. Total 28 ones this subnet mask has. So now the first 28 bits of the above subnet mask are set to 1. So the CIDR notation for this subnet mask would thus be look like just forward slash 28. That's it. This is what we call it as a CIDR notation. So now normally what happens, the CIDR mask is often appended to the IP address. So then we'll get the complete form of CIDR IP address and CIDR notation together. So let's take one example. So in this example, we'll consider 192.168.1.1 as an IP address, and let's take a subnet mask of 255.255.255.0. This is our subnet mask. So now this subnet with this subnet mask, let's see how we can represent IP address with the CIDR notation. So for that, to look that, what we have to do is first you just convert this subnet mask into binary. 255 means this octet consists of all ones. 255, this also consists of all ones. 255, this also consists of all ones. So that means it consists of 24 ones, and the last octet all are zeros, so it consists of only zeros. So only we have 24 ones. So now this can be represented as 192.168.1.1 forward slash 24. This is the complete CIDR notation with the IP address. So now let's look into the differences between address classes versus subnet mask, or the fundamental golden rules to be remembered whenever you do deal with IP version for address and subnetting. The first one is the octet. The first octet on an address dictates the class of that address, and the subnet mask determines what part of an address identifies the network and what part identifies the host. And third golden rule is each class has a default subnet mask. A network using its default subnet mask is referred to as a classful network. So when somebody says classful network, don't get bogged down. So classful network is nothing but if you take class A, so class A has range, for example, class A has a octet range from 1 to 127. And if the IP address belongs to class A, and class A has a default subnet mask, that is 255.0.0.0. That's the default subnet mask of the class A. When a class A IP address has default subnet mask 255.0.0.0, then it is called a class full network. Then it's called a class full. Then we can call this. Then we can call this network as a class full network. So another example we can take. It is entirely possible to use a subnetwork, a subnet mask other than the default. Another example that we can consider is, if you take the class B. Class B, Class B basically ranges from 128 to 129, and default subnet mask is 255.255.0.0. Any IP address which belongs to class B, if it uses class A subnet mask, that is 255.0.0.0, then that's not a class full network, that's just normal network, but that is also possible. That is also a possible, that's also possible. So remember, always remember, the only thing that determines the class of an IP address is the first octet of the address. Likewise, the subnet mask is the only thing that determines what part of an address identifies the network and what part identifies the host. So now let's move on to um, subnet and broadcast address. So on each IP network, two host addresses are reserved for Special use. One is the subnet address or network address, and second one is the broadcast address. Neither of these addresses can be assigned to an actual host. The subnet address is used to identify the network itself. A routing table contains a list of known networks, and each network is identified by its subnet address. A subnet addresses contain all 0 bits in the host portion of the address. For example, 192.168.1.0/24 is a subnet address. So this can be determined by looking at the address and subnet mask in binary. So now let's look into the binary form of the IP address first. That is, this is how it looks, and then subnet mask binary form. So this is what the subnet mask binary form. Here first three octets are 0 ones, so total 24 you have. That means these three represent these first three octets represent or defines or identifies the network, and then last octet only represents, obviously, host. Okay, so note that all host bits in this address are set to 0. So the broadcast address identifies all hosts on a particular network. A packet sent to the broadcast address will be received and processed by every host on that network. So broadcast addresses contain all 1 bits in the host portion of the address. For example, in this 192.168.255/24, in this in another example, is a broadcast address. So note that all host bits are set to 1. So this is a normal address 192.168.1.0, where if you have an IP with 192.168.1.255, all are host, all are ones, then it is called as with the 24 subnet. With the 24 subnet, that's why subnet is very important. That makes the distinction which octet belongs to a network and which octet belongs to a host. So subnet mask is very, 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 very important. So in this example, all host bits are set to ones. You see, all host bits are set to ones. So, and if you see the subnet mask remains same. This subnet mask says the first three octets identify or defines network, and last octet defines host. So broadcasts are one of the three types of IP packets. Basically, one is unicasts, are packets sent from one host to one other host, and second one is multicasts are packets sent from one host to a group of hosts, and third one is broadcasts are packets sent from one host to all other hosts on the local network. So a router by default will never forward a multicast or broadcast packet from one interface to another interface. So a switch by default will forward a multicast or broadcast packet over every port except for the port that originated from the multicast or broadcast.